Hi there. Today we're going to work on speeding up the build process, but before we dive in, let's get to know each other. My name is Alexey. I've been working as an Android software engineer for the last 6 years. Currently I work at Reddit, where I'm responsible for the core media frameworks, and I'm also a Google developer expert for Android technology. I really want to start with this picture, because in my Android reality, that dark area over there is definitely going to be this stuff. That cost me a lot of headaches when I was working as a feature engineer. And today, one of my main goals is to make that Gradle picture disappear and make you feel comfortable about it, as we're going to explore how it works, and it's going to go through the life cycle, caching logic, and so on. And our final goal for today is improve the build time. So I really want to give you some practical advices which you can try on your real product. And those of them have been tested and confirmed in a real production environment. But at first, let's answer on the question your manager probably going to ask you: build time. Why do you actually need to improve it? Why do you want to invest your time on it? And I really would want to answer on that question practically, because let's assume that you have 10 Android engineers with an average of build time 12 minutes, with 20 builds daily for each of them. We can realize that we basically do have around 1,000 builds weekly, which is 200 hours. 200 hours, your employer is going to pay you for that, and in most of the cases it's not even possible to do anything useful. And just imagine if you could improve that build time twice. It could have been as an alternative for hiring around 2 more engineers, which is actually pretty impactful. I would like also to start with Gradle a bit. There are some stuff we're going to discuss today. So Gradle has tasks, projects, plugins, it has lifecycle, caching, properties, and much more stuff. So let's start with the tasks. And the best way to explain what the tasks are is to explain what the build is. So build is actually a sequence of steps to transform the source code to the product, which is actually binary, and in Gradle, such steps called tasks. And it's not obligatory that they are going to be executed step by step. They also can be executed asynchronously. And each task has its own input. Basically, it can be anything, so like files, environment variables, and so on. It has some action to perform, and it has an output. Let's review the real task, like the most common one, which is open source, by the way. You can look through the source code in the Gradle. So it's Java compile. As an input, that has the Java version, which is installed on your local machine or on the CI. It has the source code, and it also has some arguments for the compiler. And as an output, you're going to have a bytecode. And it's also important to know that the input of the first, that output of the first task can serve as an input for the next tasks. And what actually the Gradle does, it tries to build the proper ordering for execution. And such algorithm calls topological sort in the computer science. Tasks also can be cacheable, which is great. So what does it mean? It means that if we do something which we can reuse, actually we can do that. It's not enabled by default, so tasks should be annotated as cacheable. And we're going to explore it a bit later today. Tasks also has label. And talking about labels, basically the best way to explain it, I would say that it's kind of neat information which shows us how the exact task was performed. So we have an example, and let's review all of them. We have up to date. So literally it's the best outcome you can get from your task, which means that incremental cache has been applied. So let me give you an example. For instance, if you build your code twice and all of the tasks are up-to-dated, so yeah, incremental cache is applied. But it also can be really easy invalidated. For instance, you change it, you actually compiled your build, you changed something, you compile it again, you revert it back, and you going to be able to reuse previous incremental cache. You also can have from cache, which is also really good, but of course not as good as getting Oscar or what is it? Oops. Such kind of cache stores outside of the project, and it's not enabled by default. So it's also pretty good output. You also can see that task can be skipped, which means that for some reasons it has been excluded or it has some predicate, like run if. And if you created a Gradle module, which is without any source code and so on, the tasks related to that module just can't be executed. And the worst outcome you can get is no label or executed. So the task is going to run its action. And it's pretty expensive operation. And we're going to try to avoid such executed and no label as much as we can during this talk. You can write your task literally everywhere, like build scripts, like KTS Groovy into the build src folder. Please never do that. We're going to explore later why. And tasks also can be standalone, like be a part of different plugins. You need to register your task somewhere in order to get it work, and that somewhere calls projects. Just remember that project is one of the main Gradle API. Whenever you communicate with the Gradle, actually you're gonna use the project, which has one-to-one dependency with build Gradle file, and literally it's just a set of the tasks. We also have plugins. I would say that plugins are just configurations of settings and different tasks, which can be applied to the particular project. Some of the examples, it's Android Gradle plugin, it's Kotlin Gradle plugin. Most of the time tasks are going to be standalone, so because you have an opportunity to reuse them and have an opportunity to write a test for them. And we do also have a lifecycle, and I actually know how it feels. You already know activity lifecycle, fragment lifecycle, view lifecycle, new Jetpack compose lifecycle, whatever lifecycle, and yeah, Gradle also got something for us, but it's going to be a way easier. So basically it has 3 steps, but we're going to review only 2 of them. So the first one is configuration. Just remember that in that particular step, Gradle just decides what to do next. It's going to collect all of the information from your modules and build the proper sequence of execution. And second one is its execution. It's about tasks we have. Gradle also has caching, and caching is, from my perspective, is the most interesting what Gradle has. So let's review what we have. We have Gradle daemon. It's kind of long-running process that speeds up build by avoiding the overheads starting the new JVM process. And you don't have to do anything, it's enabled by default. However, it can be not really stable on the CI, depending on your environment. For instance, it's really useful for the subsequent builds. If you, I don't know, executing assemble debug, assemble debug, assemble debug, and so on. For the CI, especially if your build agents are reusable and they are used across the company, not only Android department, so you might end up with a lot of memory leaks. And it can be pragmatic to disable Gradle daemons, but at first let's try actually to do something with that. We do also have configuration cache. So it's experimental, and it also can cause a lot of headaches to implement into the huge Android application because not all of the Gradle plugins supported it still, and it stores actually in the project directory in a hidden Gradle folder, and it also works based on input and output concepts. So such projects actually stores in our project, such cache in the project. We do also have incremental cache. Incremental cache, it's a short-term cache which can be really easy invalidated. And it stores into the build folder. Each Gradle module has a build folder, so you can see in there that there's a KSP files, KAPT files, and so on. So yeah, whenever we're going to change something related to the particular module, so you're going to lose that cache. We finished this in the project. We do also have the build cache, and the build cache, it's a long-term cache, which is going to actually remember the previous actions from you. It stores into the global Gradle build cache1 directory, and if you open that folder, you would see this stuff, which is crazy. So let's actually try to review what is it. Let's remember that we do have a Java compile task, and basically we'll have inputs, we'll have outputs, and what Gradle does when it comes to the build cache, it actually converts all of the inputs to the hash, and it actually builds based on such hashes a super hash which calls the cache key, which is actually looks like this, something similar that we have on the build cache. And if Gradle actually is not able to find any build cache, so it's gonna execute the action, which is pretty expensive. For me, it was actually really unclear where Gradle stores the build cache, because we found only the cache keys, and essentially each cache key is actually compressed bytecode. You can easily uncompress it and to see the output. We also do have a dependency cache, and dependency cache is basically just a set of jars or RRs, Java Android library or Android libraries, which are stored into the modules too. I actually have no idea why it's build cache 1 and cache modules 2. Yeah, it's like in the movie. Talking about that, we finished with a local cache, which is stored in our local machine. But we also have an opportunity to set up a remote cache. And the most popular remote cache, that's actually one of them, it's a build cache. So what actually does, it's the same cache as a local cache, which stores on the remote server, and it just copies the cache by the cache keys to the local cache, and that's it. So essentially, if you don't have like a local build cache, but you have hash keys, Gradle gonna have an HTTP request to your build cache server and try to find something in there. We'll try to download it, unpack it, and copy it to the local build folder. We also do have proxies. It's not really a cache, but if anyone remembers that Jetpack issue at the end of the year, 2 days actually, if you actually had a Jetpack library, for 2 days you actually couldn't do anything useful unless you did some hacks. And the Maven proxy actually can prevent it. So basically, it's also your own Maven, which just syncs data from all of the Maven servers to your particular one. We finished with remote cache, and there is also Android Studio cache. It's different. So if you actually have some, I don't know, mistakes, some error with with Dagger or with whatever, and if you try to execute invalid cache and restart, like stop doing that, it's not gonna help. Talking about conclusions, we have next options. So the first one, it's actually most ideal. We have our incremental cache, and we're gonna be up-to-dated, which is something we're targeting for. If we don't have an incremental cache, but we have a build cache, it doesn't matter which one, remote one or the local one, we're gonna be from cache, which is cool. And if we don't have anything, we're gonna have a no label. In Gradle, we also have properties, and properties is just a file which you can use to easily configure with Gradle. It's important to know that it's kind of two type of Gradle properties. First one stores into your local project, and second one into the global Gradle directory. Actually, I did a mistake here, so it stores inside a .gradle folder. And talking about that, during the build, Gradle gonna merge them, and the global folders are just gonna override the local properties. For now, actually, I think we are ready to do our first step. And the first step, in terms of improving the build time, like, it's never do anything but measuring first. And it also can be really frustrating because you might have a lot of questions how to measure builds properly. For instance, should you do that on a local machine? If yes, how should you do that manually, automatically? Should you set up a local build agents? Or maybe you should do that better on the CI with the CI build agents. And okay, what actually should you measure? Only incremental builds, only clean builds, and where should you send it? And how actually you're gonna do that? So let's answer on all of that questions. So the first one, if you decided to improve the build time, the most pragmatic way to do that can be doing it locally. So because basically we really want to see an impact for our engineers. So you can stop it locally daily on your laptop. You're gonna need to know about incremental build as well to see if you have consistent inputs and outputs. So incremental changes as well. For instance, the modularization usually starts that you actually would want to kind of get rid of from your application module, and I mean just reduce it. It can be really good to apply some changes to your application module to see actually that at the particular time you're going to create new modules, your incremental changes from application module are going to take not a lot of time. Clean build as well, which applies the build cache to see that the build cache serves us really good. Of course, configuration time to see an impact after modularization. And when you're going to do that, try to reduce any any external stuff as possible. So start with your monitor. No Android Studio, just try to do that with a command line. And it's going to be really pragmatic for start. The next thing you can actually consider is just to collect all of the builds automatically. For instance, you do have a lot of engineers, right? So you just want to see the real impact, and the real impact is always going to be what engineers are doing now. I would advise doing that if you have like around more than 20 engineers, because usually when you set up when you actually really want to improve the build time, you're going to set up the KPI, and it really depends on engineering environment. But if you actually want to try, there is really good tool for that, which calls Talailet. It's really easy to set up, and it supports all kind of data, or all kind of popular databases. Together with local builds, also do that on the CI, because you might tend to adopt that. For instance, if you do have Mac OS locally and I don't know some Ubuntu for your build agents, they can actually have different inputs and outputs for the Gradle, and you also need to take it into account. And how actually to do that? We don't have like a lot of options. So the first one, it's a build scan. Build scan is the most powerful. It has really good visualization. However, it's going to share the information about your build with Gradle. So you probably won't be happy about it. You can actually have a Gradle enterprise to avoid that. But I would say that build scans are pretty good to explore what's wrong with your build. To see the dependencies and so on. But if you just, here's what it looks like. If you just want to know about the numbers and to write them somewhere, the pragmatic way is going to be Gradle profiler, which is pretty easy to set up. And all you need to do with that is basically to define a scenario. And we do remember, so we need to measure everything. First thing, it's our incremental changes. So second one, it's the build cache. The third one is to see an impact from modularization. We're going to apply some changes to the particular file to build it, to see actually if we move into the proper direction or not. And of course, we need to apply our configuration time as well. However, it applies outside. And as an output, you would see basically that you do have like an HTML and CSV. So all you need to do is just to parse such CSV. The task starts in that sheet can be really confusing. So it's actually configuration time. Okay, it looks clear. Just parse it, send it somewhere. Where somewhere? It also actually can be a really great question because you have tons of options. You can do that with the InfluxDB, with the Elasticsearch, with the Graphite, or whatever remote database you do have installed for your company. But if you don't have anything, I have this stuff for you. So just actually use Google Sheets. It's really pragmatic to start, and it won't take like a lot of time from you. You can even link Google Sheet with Google Forms, and you can fill that form via just one HTTP request with a single line. So once we measured everything, let's do something. The first thing is Jettifier. Basically, it's a tool which uses to convert all of application support libraries to njoyx. Basically, when the compilation happens, you just do it via Gradle transform, which takes a lot of time. You can check whether actually you can remove Jettifier by that Gradle command, which is available from the Gradle, from the AGP 7, as far as I remember. Basically, even if you can't disable that, just continue to migrate your libraries from app support to njoyx. Here's how you can do that. So the next one is non-transitive for classes. What is actually the main problem? After modularization, you can see that basically you have a lot of feature dependencies, and all of our feature modules, like most of them, probably do have some resources like strings, drawables, and so on. And to communicate with them, actually Gradle gonna generate for us a special proxy class. So with the hashes, and by that hashes, actually they can be linked to the real drawables. And how it works, how it used to work before recent updates, basically all of your R files are going to be merged. For instance, if your application module depended on feature 1, feature 2, feature 3, it's just going to merge all of the R files, and actually it has. And the same for actually all of the modules which have some dependencies. And if you apply a non-transitive approach, it kind of looks like this. But of course, you actually need to change the way you work with your resources, because you need to define the proper module for that. And you need to do that not only with strings, but with all of resources you have. And also, it's not only going to affect the build time, it's going to reduce your application size as well, which is pretty cool. Here is how can you apply it, and a really good article with details. The next thing is virtual file system, which is now it's enabled by default, but if you have an old project, just take some time to check whether you have it enabled or not. It actually allows Gradle to keep some information about your file system in memory, because each time Gradle needs to decide what to do next, it's kind of need to do the disk hit and perform some input-output operation. And it's great that we can avoid it by using the flag. And don't use build src folders. Is there anyone who is using it for like dependencies, for instance, in the project? Oh, pretty cool. So basically, talking about that, so the most common use case for the build SRC for the Android, I would say that is KTS scripts and dependencies. And the main problem is that if you actually have done it, your incremental cache is going to be invalidated, your build cache is going to be invalidated whenever you're going to change something, and what we're going to see. Yeah, we're going to see no label, and we're going to compile our application. As a good alternative of that actually can be a Gradle version catalog, which basically has no cache issues. It can have some TOML file, which can be declared as standalone library. And it has really nice feature which calls bundling dependencies. So basically, how it works, you can just define like the versions you're gonna have, the libraries, and you can put such libraries in the bundle. And instead of connecting 3 libraries, you can just, like, you're gonna use this code, which is pretty great. The next thing is the focus, just to keep focus. Actually, it's a plugin, which allows you to manage all of your modules for the settings.gradle file. Most of the time, it's going to be useful only if you have a monorepo and multiple modules with Android application type. But at the same time, you need to be really careful because actually your inputs are going to be different. And if you have a remote cache, you need to be sure that your CI is going to contribute to your build cache as well. Next thing is Java version. Yeah, by default, we have a new standard that we do have Java 11. If you haven't migrated yet, just migrate your JVMs from 8 to 11. If you have already done that, please don't stop, because there are still plenty of ways to improve your build time. For instance, you can start with A/B testing and try Java 15 or Java 17 as well. So eventually, yeah, it's going to be also applied by default, maybe in the years, but actually no one stops you from doing it right now. And you also can tune your Gradle properties. Talking about that, the first thing after you have chosen the JVM, it's to choose the proper garbage collector. And by default, it's actually G1GC is going to be used. So basically, it can be pretty pragmatic for for the start, and it actually suits average, I would say. But if you have like modern daemon laptop with lots of memory, you probably might want to consider a parallel GC. Despite the fact that it still uses stop the word event, so it does it asynchronously. And if you have a lot of memory, it's actually you're going to be able to see the performance win. But actually, you need to test it via A/B test as well. Heap size. So we do have some JVM arguments for our Gradle daemon, and whenever we're going to define that, actually going to be automatically forked to the Kotlin daemon. And I'm not going to tell you right now what to do because it depends. So what do you really need to do from my perspective is just to choose the proper configuration for you, because configuration which works for the one company can sometimes doesn't work at all for another company. So what you can do is just you can tune your Kotlin daemon and give it more and allocate more memory for that, or do vice versa, or just allocate equal amount of memory. I would suggest you to test it and to see actually real impact, and only after that to apply it. There are also some ideas to test. However, I haven't tested them by myself, but I have some confirmation from my other colleagues that actually such stuff going to work. The first flag, disabled automatic component creation, actually going to be enabled by default really soon. But before actually taking pictures and applying all of them, just keep in mind, never apply new properties without testing. Like, don't need actually to listen to me or anyone else. You just need to test it and to confirm it on your real environment. So the next thing is KAPT. Like basically, you have Kotlin symbol processing, which is really good. If you were able to migrate in that, as minimum, you're gonna see a 25% build improvement because KSP doesn't have a stubs generation. So what KAPT does, basically, whenever you declare your Dagger component, is at first it's gonna convert it to Java. And only after that it's gonna convert it to the bytecode. But at the same time, KSP actually can do that without that step. Talking about libraries, plenty of libraries actually supported it, which is really great. However, Hilt and Dagger 2 still not supported it yet. So I would say that with Hilt you also have a problem. And one of the huge problem, for instance for me, and why I actually don't use that, because the way it works, internally it works on the subcomponents. In Dagger, there's actually two ways to declare the dependency. The first one is component dependency, and the second one is subcomponents. So Hilt works with subcomponents, and whenever you ever gonna add something or remove something, the whole your GI graph actually won't be recompiled, and it's most of the cases it doesn't matter either you have modularization or not. The really good alternative can be using Dagger plus Anvil for that. But still, I pretty like Hilt, so yeah, I'm not against it. Talking about modularization, basically there are a lot of approaches to do that. My favorite one is using API and impl just to cover an implementation and not connect it to anything. But the thing is that you need to restrict merging the new code to the application module. Whenever actually you, I don't know, someone gonna open a pull request just to fix one file or just add one file to the application module, you should not merge it if you're gonna to improve the build time. And what I propose you to not do that manually. There is a special tool for that, which is called Danger. And the way it works internally with a Git. And you can basically write a check which can perform like 1 minute and which is going to break the entire build on the CI if something has been added to the application module. After modularization, you're probably going to actually make it parallel. There is also a special flag for that, which also isn't enabled by default. And you also can have a question, for instance, how many workers I'm gonna have for that, and the answer is that you need to actually see your CPU cores, and it's actually a default value. Sometimes you might end up with a memory leaks for some of the builds. That's why you also need to do some A/B tests to choose the proper amount of workers. And after that, configuration cache. I know that there are a lot of thoughts about it that it's unsafe. We shouldn't use it at all unless it's actually ready. But I just want to show you impacts for the project with 1,300 Gradle modules. Configuration time was around 3 minutes. It's not even a compilation. You just wait for the Gradle to decide what to build. And after just 10 seconds. But yes, it's going to be challenging to implement. We also do have some extension of configuration, which calls project isolation. Currently, it's not really have a really huge impact. But you can actually try it on your project and just to see either it's going to compile or not. So what it's going to do, actually, whenever we add a new Gradle module, it's not only the configuration time, which is going to increase, our sync time with Android Studio also actually going to increase as well. So that flag is going to decrease that. No worries. I hope everything's fine. Talking about the build cache, we were talking about the build cache like a lot, and the build cache is not enabled by default. So just check your Gradle properties if it isn't enabled. Even if you don't have a remote build cache, right, you might actually have some benefits from the local cache because you're going to be able to build your actual previous result. And talking about the remote build cache, I would say that is it's the most impactful thing you can get, because one of the main problems is that whenever you're going to change your branch to the develop and to get actually git pull to see some new changes, you're not going to have some cache, you're not going to have some incremental cache, and you're just going to build and you're not going to have some labels. And how the remote build cache going to work? So we'll have a local machine, remote build cache, and Mr. CI. So only Mr. CI is going to contribute to our remote build cache. So it's going to read it, it's going to write it. So yeah, because it's Mr. CI. Talking about local machine, it's actually a good approach to have it only in a read mode. Because it's not really useful to contribute to the remote build cache through the local machines, because it's not 100% that the code actually going to be used by other engineers. And talking about that, yeah, you can just set it up that all of your jobs on the CI they are gonna be contributing to your build cache. And after that, actually, I would say it's kind of full-time job is preventing the cache misses. In Android Gradle plugin, there are still a lot of cache misses. So in the room, there are a lot of cache misses. So actually, there is some useful articles you might want to read to get familiar with that. And whenever you're going to apply the build cache, even if you apply the local build cache, there is a really cool plugin which calls build cache fix plugin, which is actually going to fix most of the known issues from Android Gradle plugin. So to always apply the build cache together with the build cache fix plugin. Sometimes we also need to see some doctor, and for Gradle we also have one. There's a plugin which calls Gradle Doctor, and so you can set it up, for instance, just to break the build for everyone who has, I don't know, not proper JVM version installed on the local machine, which is quite cool. For Gradle also we have a lot of best practices, like for instance configure the task lazily and so on. So you might want to read that article as well. And talking about other things, we actually won't be able to talk today. So the first one is extracting a native code to the libraries, because the first one you're actually not going to change it like quite often, hopefully. And the second one, it actually breaks the build cache because it has inconsistent inputs and outputs. Don't use flavors or try to reduce flavors with the build variants. Most of the time, one build variant release is going to be enough for you. If you're worrying with like how can I apply minify enabled and so on, you can easily do that with environment variables. And the main problem is that Gradle actually going to build a lot of options of your tasks, like assemble debug, assemble release, assemble your flavor release, and so on and so on. Always use latest tools, but with some concern. If you're ever going to update something like Dagger, Kotlin, Gradle, Android Gradle plugin, always measure an impact first. There are actually a lot of cases, for instance, with Kotlin 1.5, as far as I remember, actually when a lot of caches have been broken. So always measure an impact first, and only if you do have like the same numbers, ideally they actually should be better, only after that merge any changes. So yeah, it's always better actually to wait for the proper fixes for the Kotlin team and for whatever team. Talking about next thing you can do, you might want to consider the Gradle Enterprise. Yeah, it's actually, you need to pay for that. But it's actually going to be a way cheaper to just pay for that to rather than hiring a Gradle engineer for your team. And you can easily calculate ROI with that. We also have some stuff from the official guides for fixing the build time from Android and from the Gradle. We haven't actually been talking much about it. Some of the topics you're going to find for Android, actual official guide is not going to work for your product. So always actually test it and confirm by numbers. Talking about that, so the build project with 1,200 modules, so the average of the build time was 12 minutes. And after applying all of that stuff we were talking about, so currently it's 2 minutes. So Gradle actually can do the job. And today is really perfect time actually to learn about Gradle, because Gradle launched actually the free trainings, the Gradle blog, where you can learn a lot about Gradle. For instance, the training about the build cache actually was about 4 hours, which is crazy, but still, actually, you might be interested in it. And that's it for today. You can find the slides in here, and thank you.